Hi, I'm Darren and welcome to Level Up Double E Lab. Well, I finished the cleaning in the HW-101, so what did I find? What condition is it really in? Let's take a look. This beast badly needs a bath, but before I start spritzing it down, there's several items that I want to remove and clean separately, starting with all the control knobs. It's been my experience that Heathkit control knobs are pretty easy to remove, unlike a lot of older radios. Most just have a single set screw, but every now and then you find one of those with two screws, especially if it's on a higher torque control like a mode switch, or like here, on the main tuning knob. Next up is I want to remove the front panel, so that means all the nuts and washer hardware on all the controls have to come off. A 1/2-inch socket with a short handle ratchet does the trick and keeps the torque under control and minimizes the chances of it slipping off. You can start to see the original Heathkit green peeking through now. There it is. It's been hiding for decades under those washers. Rather than desolder the meter wires, I just cut them and I'll solder them back on later. Now don't loosen those nuts. Sometimes that nut is the only thing that holds the post to the meter movement. I'm down to just two screws holding the panel now to the chassis. They're in the upper right and upper left corners. Finally, the only thing holding the panel in place is just the coupling from the VFO shaft to the Jackson drive, which is a little awkward to get to, but once it's loose, the panel can be pulled forward slightly and then removed. Yeah, I did overlook the two plastic washers on the driver tune control. Easy to miss them amongst all that gunk. It's really hard to appreciate from the video just how thick and glossy and nasty that congealed goo really is. I was not optimistic that it would come off cleanly, and yes, that's a foreshadowing of what I'm going to show soon. But I'm jumping ahead. Next item to remove is the VFO. I took it off for several reasons. I need to inspect the inside of the box it's in, and removing it gives the best access. And once it's removed, it's a lot easier to clean it and under it. The final reason was it had to come off in order to give access to the mounting hardware holding the two bandpass filters to the chassis, and I definitely wanted to remove those and not expose them to the chassis cleaning process. The last item to remove is the cover over the filter modules. I need access to the 4 circuit boards underneath it and also access to the band select switch stack for cleaning. As you'll see once I take the chassis outside for cleaning, I do use masking tape over the coils to limit the amount of water that gets in them. That's it for disassembly. Time to take this filthy pig outside. Alright, I've got everything set up outside, so let's get to cleaning. Those with weak stomachs may wish to fast forward through this next part. I open up all the variable caps so the cleaning solution can get to the vanes easier. Normally you want to keep those fully meshed when you're working on a rig to minimize the chance of any accidental damage. I start at the top so that I'm not washing the dirtiest water back over an area that's already had a cleaning pass over it. It's actually kind of satisfying to see just how fast this solution starts cutting through that gunk. Look at those little streams of brown ooze flowing down the chassis. For sturdier surfaces I use an old toothbrush to lightly scrub them. For more delicate surfaces like the printed circuit boards and the components on them, an acid flux brush works great. Notice the masking tape that I mentioned earlier. Now it's not watertight, but it does minimize the amount of water that gets into those IF cans. The only other consequence for using it is that I have to hand clean the cans later. I mentioned before that the cleaning solution is a 50% mixture of a product called Super Clean and 50% water. Even diluted, it's still a strong base, so I don't like to leave it on for more than about a minute. And what I've noticed, after about 30 seconds or so, it's already removed about as much of the gunk that it can. For thicker deposits, you need to rinse it off, apply a second spritzing, and scrub it a second time. Or like for the super nasty SB600 case that I showed in the prior video, it may take 5 or 6 of those applications. To rinse it off, I'm using a regular old pump sprayer filled with regular old tap water. I don't think deionized water is really necessary. I mean, after all, this guy is not going to come so clean that any mineral ions left behind after the water evaporates are ever going to matter. Alright, from this point on I'm speeding up the video since it's just more of the same. One thing you guys might be wondering is, Will all of this water exposure damage these PC boards or the components? The answer is no, it will not. For the amount of time that the boards have liquid water on them, which is only a few minutes before I put them in the sun to dry, there's no concern. There may be some very old board materials that might be of concern, but boards from this era are typically phenolic resin and paper, which can withstand short exposure to water. But as always, if you're doing this on your own radios, you're doing it at your own risk. The paper covers on the electrolytic caps will absorb some water, but I'm replacing them anyway, so that doesn't matter. All the resistors, ceramic caps, tube sockets, and so on are not in any way harmed by this brief exposure to water. And considering just how much more effective this method is versus trying to spot clean something of this size, there's no comparison. Now I know there's anecdotes on the internet about guys that swear about putting these old chassis in a dishwasher to clean them. I guess each to his own, but to me, I would never put anything even remotely this filthy in an appliance that's going to wash the plates that I eat off of. Okay, now it's time to clean the front panel. And believe me, I'm very nervous about cleaning this part because of possible damage to the paint. But again, I cannot emphasize enough just how bad and nasty and thick this coating of tar is on this panel. So I really had no choice but to use a cleaner that was sufficiently aggressive to get rid of it completely. That tar had to go. And as I feared, the paint was coming off with the tar. You can see right here that beautiful Heathkit green paint dissolving. Actually, it looks like even just plain water was enough to dissolve the paint, even without the cleaner. So either the tar residue greatly weakened the paint, or it was already weakened just by age. Either way, this is now a big issue, because if I am able to restore the radio to full function, I obviously want a decent looking front panel. And here's what it looked like after it dried. I'm sure the most die-hard Heathkit fans out there are yelling at me now. Unfortunately, the patient did not survive the cure for the disease, but all is not lost. I'm not the first HW-101 owner who's needed to refurbish a front panel. A quick internet search turned up a self-adhesive die-cut applique repair option made by Kevin Mahoney. For $40, this seems like a reasonable way to restore it to near original factory appearance. Alright, I finished all the cleaning, and surprisingly, the chassis did clean up very nicely. I will inset some video here to show some of the highlights and pan over the top of the circuit boards, and as you'll see, the silk screening still looks very nice on the printed circuit boards. There's only a few areas, I'll point them out, like here and back here, that looks like there's some kind of gunk that didn't quite come off, but it must have been on there before all the smoke residue got there, so I'm just gonna leave it alone. So I did spend about 3 hours going over it with cotton swabs and little cotton wipers just to use some of that diluted cleaning solution, and then go over it with some water to get some of the spots that the method couldn't get when I was washing it outside. So I'm very encouraged with the way this looks. On the other side, and I'll show an inset video for that as well, the wiring and the soldering look pretty good. There's no corrosion that's of a concern. The wired harness and the individual wires themselves look pretty good. Now, there still could be a risk that some of those connections have degraded, and even some risk that the insulation maybe has broken down. But that seems unlikely. I mean, just looking at the condition of this and compared to other radios that I've cleaned in the past, again, I was impressed with how well this cleaned up. Now, there is one thing that you have to be careful of with that cleaner, even just on unpainted surfaces, and it'll kind of show up here on the body of the VFO. And I'll try to get it in the camera if I can. There we go. You can see it here. There is discoloration that happens with bare aluminum, and that's to be expected. The cleaner's a strong base. If you leave it on there long enough, you're going to get some discoloration. But I'm not worried about that. These are not cosmetic surfaces. If this had been a outside surface that was visible, then that would be more of a concern. But generally, that's the only thing you have to worry about with that cleaner with bare aluminum. Okay, so moving on. Other checks that I've done at this point, I have spot checked the resistors. I've checked about 20 of them, and I saw only one that was about 10% high, so that's encouraging. I will go through and check them all. There's absolutely no reason to trust any of the resistors until I've proven that they're good. I've also cleaned and lubricated and checked on the ohmmeter all of the potentiometers, and that's always a hold your breath moment, because if you get a lot of those that are bad, that can get expensive in a hurry. And fortunately, I've only found one, and that's the audio control. I think it's over here underneath the selector switch here that checked intermittent. So that is probably going to have to be replaced. It also has a switch on the back of it, which makes it a little more expensive to have to replace. But nonetheless, that's the only one that I've seen that was bad. I was really concerned about this guy right here. That's a 200 ohm, I think it is. That's the carrier balance potentiometer, and I'll show an inset video. That's a particular style that Heathkit used. It's soldered to the board, and you can't find them anymore. And you generally have to cobble in something that just barely aligns, and I've not had good luck finding anything that's a really good fit. But that one checked out, so we should be okay. I'm going to flip the chassis over at this point so we can take a look at the bottom side. All right, here's the bottom side of the chassis. It looks pretty good too. Now, it started out much better. It didn't have that thick coating of tar on it, but nonetheless, it looks really good. As I mentioned, I don't see any large areas of corrosion or damage in the circuit boards. The wiring looks to be decent. There still could be some problems with it when I put high voltage on it, but I won't find that out until I power it up. Now, one smart check to do on an old radio like this, especially one that has an external power supply, is just take your ohm meter and do a continuity check on the main power connector, this guy in the back right here. What I did was just quickly check to make sure none of the high voltage or filament voltage inputs were shorted to ground. If they were, now's the time to catch that and fix it before you get deeper into restoration and repair. That checked out fine, and the pins that are supposed to be grounded are grounded. The next thing I did was check all of the IF coils and the ones on the other side as well, the IF cans. Make sure none of those are open circuit, and I think these I have to go double check on the schematic. Some of them might have some parallel resistors across them, so they may not be 100% reliable, but still worth the time to check and see if you just happen to catch an open circuited coil. I also did check all of the contacting switches on both sides, even this guy right here, the double stack one here, to make sure that the continuity was right, and then at the same time I cleaned them. Now, the way I do that, I use a cotton swab. I just dip it in mild contact cleaner and just wipe the actual contact surfaces very gently. In areas where I have better access, use a pencil eraser. This works extremely well to get that black tarnish off, but again, only in those areas where you can access and reach the contact surfaces. If you can't, just use the contact cleaner. I much prefer to do it that way rather than just wholesale spraying it on there, because that makes a mess. And they cleaned up nicely, and like I said, continuity checks look good. So all in all, the assessment so far looks really good. And at this point, I will finish the list of what I think are going to be the major items that are going to need repaired and my estimated cost. I haven't forgotten the HP23 power supply. It's actually in better shape cosmetically than the HW-101. Maybe it was more sheltered inside the speaker housing from all those clouds of smoke. But at a minimum, it'll certainly need all the electrolytics and diodes replaced, and possibly all of the discharge and bias resistors too. Removing the bottom cover did not reveal any surprises, so that's good. All the caps are still intact, and nothing looks like it had ever exploded or overheated. I need to disconnect the 6 Henry choke and confirm it's still good, and it is. It measures just fine on my simple LCR meter. Now for the power transformer. If this big boy has issues, then that's a whole new can of worms. Alright, so I'm down in the lab, and what I've done here is I finished checking the transformer, primary and secondary, with the ohm meter, and didn't see any problems with the resistance values. So what I want to do next is actually apply controlled AC voltage to the primary and see that the secondary is working correctly. So what I've done before this setup is I've disconnected all of the diodes and capacitors from the secondary side of the transformer and connected up 3 multimeters, and I'll show with just a couple arrows here which one is which. So first of all, I have a multimeter connected to measure the AC filament voltage. That should be between 12 and 13 volts. The middle meter will measure the medium voltage secondary, looking for around 125 volts, and both of those are AC voltages, of course. And then my trusty IM13 vacuum tube voltmeter, I'm using that to measure the high voltage secondary, and that should be around 270 volts AC. And looking at the scale on the meter itself, that should be just over mid-travel of the needle. And of course, anytime I'm doing testing with AC voltages, I'm using my dim bulb tester, which I featured in several of my episodes at this point. And if you're not familiar with it does have an isolation transformer, does have an auto transformer in it, so I can vary the voltage. And as I always say, I'm looking for that light bulb in the back to not glow. And in fact, I need to move the meter over a bit so we can see the filament better. There we go. So I'll be turning up the AC voltage slowly. I'll get it up around 115 volts, give or take, and see what the readings are on all three meters. So here we go.
This item contains hazardous voltage and safety precautions must be followed. If you're following along and working on your own version, you're doing so at your own risk.
And I'll pause here around 60 volts or so, just to see what things look like. 7¼ volts on the filament looks good, about 70 volts on the medium AC, and looks about 175 volts on the high voltage AC. So that looks good, and of course there's no glow in the bulb. That's even better, so let's keep going. And I'll stop here around 115, ought to be good enough. And looking at the readings, 12.8, that looks good. 125, that looks good. And that needle on the vacuum tube voltmeter is around 280-ish, give or take. So that also looks good. And of course, the indicator is glowing on the power supply. So this is good. It looks like I've got a good transformer here, and I can proceed with rebuilding this power supply. So all things considered, this is really in pretty decent shape. It cleaned up nicely. What I found so far is fairly straightforward and easy to repair, so it could have been much worse. After stripping off all that gunk, I could have found some really serious problems there. So now looking at the summary of the work that's ahead of me, I'm going to show on screen what I've estimated for repair costs. And like any old rig, you don't really know what the repairs are going to be and how much they're going to cost until you start getting into it. But this is what I see right now. So for the HW-101 itself, for sure, I got a front panel applique I'm planning on buying. A couple of replacement tubes. I mentioned earlier that the 6HS6 are very expensive and a little harder to find, but I'm going to try to replace them rather with a pair of 6AU6s, and they're not very expensive. Capacitors, resistors, of course. I do need to replace that volume potentiometer, the AV control on the front panel, or on the front control panel rather. And then paint and primer, going to need a lot of that, both for the case for the HW-101, and I'm also showing for the speaker too, the SB600 speaker. I need to repaint it for sure. The power supply, got to recap and replace the resistors in that. I would have loved to have bought a pre-made printed circuit board for that power supply, but it looks like Mike over at the heathkitshop.com unfortunately is not taking any orders right now, but the board's not that complicated, so I'll just fab one using my own design for that. So all that totals up to around 180 bucks. I paid a whopping $30 for the whole set at the Hamfest, so I'll be into this for just under or just over $200. That's not unreasonable, because if you think about it, this rig sold anywhere from about $400 I found in 1970 in the Heathkit catalog for 1970 all the way up to $900 in 1983. And if you convert that by inflation to today's dollars, not counting the fact that inflation is almost 8% now, but nonetheless, I mean, that's around $2,600 to $2,900 is what you pay for this today. So from a practical standpoint, that's not that unreasonable to spend about $200 to restore an old rig like this. And like I mentioned earlier, there aren't any more of these being made. These are all there will ever be in the world and then even fewer, going into the future. So anytime you can find one that you can get back into service is definitely worth considering. So I hope you enjoyed today's video, even though I got into some surprises with that panel and have to come up with an applique to fix it. As usual, leave comments below if you'd like, and thanks very much for watching. So until next time, bye for now.